2-butene reacts with bromine water, resulting bromohydrin and treated methoxide and methanol. Undergoes intramolecular SN2. Butene bromohydrin and treated methoxide and methanol. Okay. Undergoes an intramolecular SN2, taking into consideration the serial chemical consequences of the reaction mechanism. You want to choose the final product. So Z2-butene. Z is going to be the cis-wide form. Okay. So okay, this burr first forms the bromohydrin. Reacts with bromine water, forms a bromohydrin. Okay. So that this correct. Okay. And I'm going to be having this particular case here, opposite attack here. Okay, so let's start off step by step. Let's not go for the answer there directly. So I'm going to be having 2-butene in the cis form there. So that fellow is going to be targeted by bromine water. So if I'm going to be having bromine water attacking here, what will be the products formed here?
Yes, sir. That. Sir, what?
These two locations become chiral.
Yes, sir.
So if they become chiral, what are the products formed?
Now, 1 second.
I will have enantiomers.
Yes, sir.
Mixture right?
Yeah.
So if I do get a racemic mixture there, I'm going to be having both possibilities clearly available. Yes?
Yes, sir. Yeah.
So once I have that applicable, now in the next case, I'm going to be hitting this with methoxide. The methoxide fellow basically ends up doing this. It will attack this hydrogen, pluck that fellow out, you get an O minus.
Yeah.
So then we end up having the O minus, which is generated here, will go and attack this fellow and kick this guy out, which is going to be resulting in our product over there. Now the question becomes, what is going to be the configuration at each of those locations?
Okay. Yes, sir. Yeah.
Now I think you are getting closer to the answer directly by yourself.
Yes.
What was your issue here? Where did you get stuck? Why
So
do we have a confusion?
I don't know. Like,
I can see what you have put there. You messed up with putting bromine and bromine.
no, sir. That was something else. I know that was wrong. I should have released that. Yes.
What was the real issue here then? What's the answer given here?
Sir?
What's the answer for this question?
Second. 1 and 2 are equal amounts, sir. D, sir.
That seems fair. Why will they be equal amounts, by the way?
So because it'll be, why would they, the
racemic mixture.
Exactly, yeah. When this thing, why would, yeah.
You're getting enantiomers in equal quantities. So
Exactly, yes.
You understood what you needed to understand here?
Yes, sir. Yeah, I could have.
What was your confusion? Let's go there. I thought I would not want to confuse you more, but this is a straightforward question. This should not have been out for you.
So wasn't like my options were matching when I first did this. I don't think I messed up somewhere in this key.
This is MS Chauhan?
Yes, sir. Yeah.
I thought you would be doing that Akshay series or whatever.
That blue thing.
You've not yet graduated to that stage yet.
Not yet.
Okay. उसमें से questions आ रहा है क्या तेरे internal exams में?
Sir, what?
that other book which you sent? Are they
Yes,
asking questions from that, or are they
not
asking questions from MS Chauhan in your weekly exams and all?
sir. From I think Himachal Pandey they gave few questions.
हिमांशु पांडे से मिल रहा है, ठीक है.
Yes. Sir. Okay, but
Next one.
this is.
You understood what you need to understand here? Yes.
I understood, sir. I understood. Yeah. I sent it, sir.
The following groups is the strongest. Right. Which group we have a problem with?
Sir, my answer is not matching with the thing.
Okay, all right. Okay. So CH3O minus, C2H5O minus, CH3S minus, and methanol. In the first bunch there, second fellow is the best guy. Okay, so that directly gives answer as well. So not second fellow, third fellow is the best guy. Damn. S minus is better.
So
third guy, that means that is 1 and D. A and D. Okay, so two possibilities open up. So among the two possibilities, we are having everything is nice and different. Okay, let's look at the second one. DMF. DMF. DMF it's going to be NH2 minus, which is best, clearly.
yeah, that's what. But it's given OH minus is better.
What?
Yeah, the key is given OH minus is better.
Right. Maybe I screwed up. Let's see. Dimethyl formamide, right? So formamide. Okay. So formamide dimethyl. This is proper polar aprotic.
Yeah, that's what I was thinking. Obviously, it will be NH2 minus or then.
NH2 minus, they're fucked up.
Okay, fine.
Is better there. And let's look at the third one there. Third one. Also should be, third one also should be 3.
Yeah, that's 3.
The answers are wrong, done. It should be 3.
Yeah, that's what I was thinking. Okay.
Answers are wrong here. They gave Delhi as the correct answer or A as the correct answer?
Delhi, sir, Delhi. Yeah.
They've got both parts there slightly wrong. All 3 should be 3.
Yes, sir. Yeah.
Okay, none of the answers are correct actually.
Yeah, that's right.
Okay, next one. So your logic is not wrong here. It's fine. It's correct.
Yes. The second part.
What will be the effect of increasing solvent polarity on the rate of each of the following reactions? The second thing is a problem, is it? B.
Yes, sir. Yeah.
Okay, RL plus R plus L. Increasing solvent polarity. So when I'm increasing solvent polarity, what will happen? What will happen? Why is the first one getting better according to you if you increase solvent polarity? You marked it as a
yes, sir. Yeah.
Why?
Sir, I thought the the will be more stable, like the.
Which is more stable?
Sir, what?
When you say stable, what do you mean by stable? Which gets better? If I increase solvent polarity, what is going to be more stable? Charged species?
Charged species, yes.
Correct? Because when I increase solvent polarity, that means the charged fellows are going to be more nicely solvated.
Exactly, yes.
So in the first thing there, the logic should be that it has nothing to do with cation pools L minus and whatever we have scribbled there. The idea there is your products are more stable in the what to say system where there is more polarity, which means forward direction is favored. You understand how to see that?
Okay.
Now apply the same logic in the second case there.
Then
The leaving group does not have a negative charge.
yes,
Both my
but
systems are having a positive charge.
yeah,
Reactant and the product.
yeah,
Right. So
yes,
in this particular case here, solvent polarity increasing should not really affect both sides by beyond, or say, it should not really change it too much. If it does favor something, it will probably favor RL plus remaining as it is. Backward is probably going to be more favor because the L is leaving with the lone pair, and I don't know how stable the R plus is going to be. Technically, though, yeah, it should not matter. I would say solvent polarity here might decrease over here if I'm increasing solvent polarity. What is the answer given for Bombay?
that's given decreasing, sir.
Yeah, that makes more sense. Why it makes more sense over here is because you're going to be having octet configuration retained only in the reactant side. If I'm taking the R, let me put it down here and show. If I take this system, all right, in this here, both sides are going to be favored by the solvent being more polar. That is, I'm going to be having this guy and this guy. Both are going to be better in terms of favorability. But if I consider the reaction as an equilibrium, now I'm going to be considering that both of these are going to become more stable. Which one's stability is going to be more important now? Which one is
And
inherently better? The RL plus is inherently more stable than the R plus. Why? Because the L is taking the lone pair and getting out, right? That means this R plus does not have octet.
okay, okay.
So think like this. You know, during the COVID time, cash was pumped everywhere.
Yeah,
Who really got richer? When cash was given everywhere, what did people
yeah,
do? People had extra cash. What did they
yes,
do with extra cash? They parked it,
yes, exactly.
park it
Yeah,
in assets,
yeah,
in stuff, in luxury
yes,
goods, and in stocks and
yes.
bonds. Who did they really benefit? The people who owned the companies which made all of that shit.
Exactly. Yeah.
And the people who owned the companies of which the stock which was bought, they benefited a lot more.
Yes. So done the yeah.
Right?
Yes, sir.
So in this particular case here, when you are making both sides extra stable, the one which is inherently more stable will benefit a lot more.
Okay.
I'm going to be having the system now. Currently, it's an equilibrium. Everything is equilibrium.
Yeah.
So this guy is in equilibrium. In that equilibrium, I'm going to be having something now added in, which is benefiting both sides, reactants and products.
Yes.
Not by what to say, it's giving both of them an extra benefiting factor, like say an X multiplying factor. When you give both of them a multiplying factor, the one which is already more stable will benefit by a huge margin, by a much larger margin, because the multiplying factor is what is added here. It is not an additive factor.
Okay.
That's why the analogy I gave was the COVID thing either.
Good. Yes.
Think during COVID, what happened? Who became richest fellow for a while? Louis Vuitton dude.
Yeah.
Why? Because people went and bought his products.
Yes, exactly.
Amazon dude became extremely rich. Why? Because people went and bought stock.
Yeah.
But the money was given
Yeah.
to whom? Were they given the money? No. The
No.
money was given to common people. In the
Yes.
world, across the world, people, the countries printed money, they gave it to common people. The common people went and bought these things.
Yeah.
So the person who was already more stable became even more stable.
Yeah. Yes.
You understand the idea here,
Okay.
right? In this case here, both are going to become more stable. I'm not saying the products are not going to be more stable here in the polar protic solvent, if I'm increasing polarity here. But the reactant stability is becoming even more enhanced compared to the products.
Yes. Yeah.
Which is
Correct.
why it's
Yes.
moving back. Not because of any
So.
other thing.
Okay.
You have to go with
Yeah.
Lishat. What was your doubt here? Your doubt probably was along the lines of carbocation should be, or the R plus should be more stable in a polar protic solvent. So why is it
Yeah.
not going more in forward? Is that the doubt there?
Yeah. It was something like that. And plus, like, we wouldn't really know whether the R is stable or not, right?
That's the point here, now. When
Yes,
I
sir.
don't know whether the R plus is stable or not, but I damn well know the RL plus has octet.
Yes. Yes.
For damn sure, I know that will have octet, right?
Yes, sir. So
The
if
R
that
plus
were,
may, does not is not the correct thing there. I should not have used does not over there. May not would have been a better term.
sir, in some cases that this would, like, if there was like a tertiary carbocation, then would it still
See,
decrease?
let me put it over here in a way in which it will basically give you the answer you're looking for. You're asking when is a possibility that this might
Exactly.
be pushed in forward. Is that what you're asking?
Yes, sir. Yeah.
If my RL plus is going to be having the L attached to an extremely heavy sterically hindered site, which
Yeah.
hinders my solvation for the RL plus. But solvation
Okay.
is possible for R plus. In that case, it might go in forward.
Okay.
You
Okay, sir.
understand what I just said, or should I repeat it?
Yes. No, I got it. Yes.
So only in that case, only in those kind of cases, where I'm going to be having the RL plus because of steric factors is going, if that becomes a problematic location for solvation, then I will end up having possibility of forward direction being more. In almost all other cases, it will be backward only.
Okay.
Next, you understood what you needed here?
Yes, sir. Yeah, I got it.
Okay, next one.
1 second.
You're in fine form, dude. You've not asked shitty questions. You've asked some decent questions today. Means you're starting
Yes.
to understand organic quite nicely then.
Yes, sir. Yeah. Sir, I still feel my hydrocarbons is pretty weak though.
There's nothing wrong with feeling hydrocarbons as weak because that is the starting part there. Your connections to hydrocarbons are starting to be formed. So relax.
Yeah, after SN1, SN2 started, I started feeling a little comfortable. Like,
Because you started making connections properly now.
yeah, and then I could like finally understand like even E properly, like elimination. Like back then, I didn't really clearly understand, but now I feel like I've gotten more clarity on that
Yes,
due to
because you didn't
SN1. Yeah.
you're not supposed to have understood that because nothing was
Okay.
given there as information. Nah?
Yeah. Yes.
The connections all come in alkyl halides here. In fact, aldehydes and ketones, it will get better.
Hmm.
Oh, okay, what is this? Nitration
So,
order. Yes.
so like for an exam, like how do you like? What would you advise? Like, how would you advise me to revise for
For which
alkanes and
exam?
for the like a final exam we have, right?
This
Grand test.
exam.
Yes, sir. Yeah.
Okay.
We only
When
have
is the
organic.
exact exam?
27th, sir.
April?
Yes, sir. Yeah.
March 27th or April 27th?
April, sir.
April 27th. By that time, what is the expectation of them completing how much?
Gigna Jason, sir, until then.
Only up to there.
I think so. Wait, 1 second. I'm pretty sure it'll be up till there, but
Gets
then
in, once gets in or
I don't think it'll come, sir. I'm pretty sure it won't come. 1 second. So like we started aryl halides yesterday, so I think maybe Gigna Jason will have.
so alkyl halides, aryl halides, and then Grignard, and they close.
Yeah,
So
I
I'll
believe
call
that will be.
inositors also then.
No, sir. I don't like. We'll have online classes in April, but I don't think they'll complete that and give it for the exam.
Oh, छुट्टी है क्या तेरा?
Yes, sir. Yeah.